Let's talk about echelon form of a matrix. So echelon form, say we are given a matrix A. So A, when do we say that matrix A is echelon? So the first property that it should satisfy is that all non-zero rows are above any rows of all zero. So let me write it down. All non-zero rows must be above rows of all zero. So it means if we have we have matrix. Suppose one of our row is 0 0 0 1, and it is 0 0 0 0 another row. So this is echelon. But if there is another row which is like 0 2 3 0, then this is not echelon, because this is a zero row and this is a non-zero row. So the zero row must be, must not be above any non-zero row. It should be most it should be very, it should be at the bottom, and it should be at the bottom. The zero row should be at the bottom. It should be at the bottom for a matrix to be called in its echelon form. It should be at the bottom. Okay, this is the first property that it should satisfy. The second property that it should satisfy is that the leading entry. You know what is leading entry? Leading entry is the leftmost non-zero entry, non-zero entry in a row. Okay, the leftmost non-zero entry in a row. So for example, if we are given like 0 0 2 0, this is one of my row. So here the leading element would be 2. If it is 3 0 9 8, 3 is the leading entry. 0 8 0 9 8 is the leading entry. So that is what leading entry is called, the leading entry. So the leading entry of any row, let me erase this, of any row should be towards the right of leading entry leading entry of previous row. Now what does this mean? For example, one of my row is 2 3 0 5, and another row is 0 9 8 2. So if we see that 9 is to the right of 2, the leading entry here is 2, the leading entry here is 2, the leading entry here is 9. 9 is to the right of 2. Let me write another row. Let's say 0 0 5 6. Here 5 is to the right of 9. No, the leading entry of any row should be towards the should be towards the right of the leading entry of previous row. Leading entry of previous row. So 9 is towards the right of it, 5 is towards the right of 9. So if we suppose we say take another row like say 0 8 9 6. Now this matrix is not echelon, because 8 here 8 here is not to the right of 5, it is to the left of it. Or even if we if we write 0 here, and we write it like this, 0096. Again, 9 is not towards the right of 5, so it is not echelon. If this row, because of this row, this will not be an echelon matrix, not be an echelon, not echelon. Okay, so the another property that it should satisfy, this is two property. The third property that an echelon matrix should satisfy is an echelon form of the matrix, that all entries in a column below a leading entry is 0. Let me write it down. All entries in a column below a leading entry is 0. All entries should be 0. Like if we say here, this is the leading entry, all entries below it, all entries below it are 0. This is the leading entry of the second row, all entry below is 0. Now 5, it's the leading entry of this row, and if we do not have written this 9, if instead of 9 we would have 0 here, 0 here, then this is an echelon matrix, right? So the leading all entries in a column below leading entry. So it simply means that entries below leading entry are 0. We can also say entries below leading entry are all 0. This is basically the same thing as the property 2. So that's it. So let me give some examples. So you will have to tell whether it's echelon or not. 2 2 3 0 0 1. So is it an echelon matrix or not? So this is the first row. The leading entry is 2. Fine. All the entries below 2 is 0. Okay. This is the second row and the leading entry is 1. And it is to the right of 2. Right? It is to the right of 2. So yeah, this is an echelon matrix. This is echelon matrix. Right? Let me take another example. Let's take another example. Say -1 0 3 over 2 1 0 7 0 2 0 0 0 8. So is it an echelon matrix? -1 is the leading element here. All the elements below -1 0. This is the leading element, leading entry. All the element below is 0. Fine. Now this is the leading entry, and the leading entry of second row is to the right of the leading entry of the first row. Leading entry of the third row is to the right of the leading entry of the second row. So yeah, this is echelon. This is an echelon matrix. Another example. Let's take another example. 4 0 5 0 0 0 0 0 0 9 0 1. Right. So this is my leading entry, and there is no leading entry here. This is my leading entry. So this is not echelon. Not echelon. You know why? Because this does not satisfy the first property. The first property says all non-zero rows must be above rows of all zeros. So yeah, this is a non-zero row. This is a non-zero row, and it should be above row of all zero. This is a row of all zero. It should not be above this. If it's above this, this is not an echelon matrix, right? This is not echelon. So you might have got an idea of what echelon matrix is. Let me come to another kind of matrix which is related to echelon. It is called basically reduced row echelon matrix. Now this is important. Reduced row echelon matrix. Now this is an echelon matrix. This is also type of echelon matrix. The only difference here is it is an echelon matrix. It is an echelon matrix with leading elements of each row barabar 1. So every leading element of each row should be equal to 1. For every row, the leading element should be equal to 1. So the leading element of each row is 1, and each leading element 1 is the only non-zero entry in its column. So it is basically the same thing. Let me take an example. So you have to tell whether it's echelon or not. 0 1 0 5 0 0 0 1 0 0 0 0 0 0 0. So is it an echelon matrix or not? So here leading element is 1, leading element is 1. So is it an echelon? No. But this is a row of all 0. So the leading element of each row should be 1. So there should be a 1 also here. So this might not be an echelon matrix. So if we take another example, 0 1 0 6 0 0 2, let's do that, 0 1 2 9, 0 0 0 0 1. So here leading element is 1, here it is 1, here it is 1, and all, and the second entry is to the right of first, the third leading entry is to the right of second. So yeah, this is an echelon map, an echelon, and also a echelon reduced echelon matrix. So that's it. See you.